Lot. I can see that already the front rows have gone vacant, but I'm committing to you, the guys sitting in the last bench, you will wake up as I go through my presentation because both Mr. Deshmukh and Mr. Sharma were almost swore me that I cannot come up on stage and talk products. So they were like hounding me. I didn't share my presentation with them, and they were worried that what am I going to talk about. But as I committed to them, it's not going to be a product presentation. I'm going to probably throw some things at you which will make you probably think a bit when you leave from here. So title of my presentation is Future of Making, and I'm basically going to touch upon two topics, future of making and something called generative design. For those of you who are borderline into additive and into design, you would have probably already heard of generative design, and I'll show you the Autodesk version of generative design. With that, let me just start with a small video. Sound. Yeah, so I'm sure if not for my voice, but the audio in the video would have woken you up. So now that I have all of you attending to what I'm trying to say, every image, every video that you saw in that piece of video was work done by our customers, on our products. That's the kind of stuff people are doing, and that's what we call as our vision, which is helping people to imagine, design, and make things. And what I'm going to talk today to you is about where is this future of making headed to. So ever since man came to earth, I think we've been prone to making things. We make things. We constantly are making things, whether we are at home, whether we are at work, we are constantly making things. And if you actually look at in the IT domain, there had been a very simple view to how do you make things. So you have a man, you have a machine, and there you have an output called the product. It was basically a very linear cycle that the product used to follow. And then the product used to retire, and that was a fixed product value for every product. That's how making has evolved. And the output that you get in a linear process is something like what you see, right? This is what you get when you follow a linear process. But what's actually happening today is things are evolving. Things are evolving all around us, right? So whether you look at the statistics of smartphones, data usage, internet access, connected devices, all these things are happening around us, and these are driving a lot of change in the way we make things. And that's exactly what is the central theme of my presentation. Overlay that with the way we are involving our senses into technology. So technology is now kind of that border between a human being and technology is getting lesser and lesser. There's no partition there. So we are kind of trying to appeal our senses and hence challenging technology to deliver more and more. And this has got proved over a period of time where technology evolves, the costs come down, and the utilization goes up. A classic example that you see on the slide here is of the number of photos that we take today in the digital world. At the break, I was just checking to quote that number. I have 1,200 and 391 photos on my phone. 12,391 photos, we would have never even imagined that this is the kind of data we are carrying with us, and this is just in one folder. And I'm sure the numbers might be pretty similar. But this has all started happening because technology is being forced by the senses, and technology is fast evolving. So basically it is us, the customers, who basically are demanding this, whether it's got to do with mass customization that we keep asking for, or it's personalization, or smart technology, or synchronization, a real-time feel that we need. That is what is driving all this. And hence, advanced manufacturing, not mere manufacturing, advanced manufacturing, real-time manufacturing is a reality. It's already there. And that's exactly what we say is going to be the future of making. So what exactly is the future of making? So you see this linear product life cycle. When you talk of future of making, it is cyclical. It's a closed loop mechanism which works, and that is what companies are heading towards. And each of them as a function is interconnected to the other. And basically the product is offered as a service. And constantly you keep innovating based on the feedback, and you keep looping it back to the development, and hence getting a better product out of it. And that's what is happening. And that basically results in nothing but a much better output, a much output which the consumer wanted or consumer desired for. So basically what we are talking is a platform which has all the elements of from design to make and to use. So it's a platform that companies will adopt, and it will be a closed loop mechanism that will work, which will ensure that the product is constantly innovating based on what the customers are asking for. And what we at Autodesk call it design, make, and use. And that is what our products are also moving towards, to ensure that the customers are able to leverage it to the fullest. And the output is not a linear output. The output that you get is exactly what you feel or what you want it to. That is what is basically the evolution that is happening. How does the future of making work? Very elementary, no rocket science. You have technology, you have people. That's how that initial slide which I showed you about, there is a computer, there is a man, and there is an output. But what is happening to technology today is there are multiple elements in technology. There is AI that is coming in, there is knowledge automation, there is unlimited cloud computing power that's available, and of course there is generative design, which is what will lead me to my next topic. And that, clubbed with human intelligence, is what creates innovation in technology. So what's generative design? And this is the crux of my presentation basically. So in a traditional way in which you would design a product, a design engineer will sketch out a few options. You will deliberate those options based on what you want to do with that particular design, how you want to machine it, what's the strength, what are the priorities that you have. But the fact of the matter is you're starting with very limited options. The limited options is based on what that human mind there has to offer, correct? And then you have the traditional processes that follow, which is manufacturability, evaluation, and validation, and then you go to production. Now imagine if there is a tool available which throws up thousands of designs. A tool that throws up thousands of designs based on parameters that you have defined. Based on material, based on machinability, based on temperature, based on tensile strength, whatsoever you may want, you define that, and the machine throws up thousands of designs to choose from, and that's where you start. And just see what happens on the x-axis. Your entire process gets compressed, your time to market goes down drastically, and hence your efficiency and so on and so forth follow suit. So, and who does this affect? Believe me, everybody in this room, because design is the starting point of any innovation. Design is the starting point of anything that we do in manufacturing. So it pretty much impacts all industries. And how can you make most use of it? You have to embrace it. And you would say, why is Pankaj saying you have to embrace it? Technology is there, people will embrace. But the biggest problem here is going to be how we look at things, how we change our mindsets, and how we make our customers change the mindsets. And that will probably get covered in the later part, the last part of my presentation. So basically, it's all about knowledge automation, the generative design, and finally the production. And I want to quickly show you what I'm talking is not theory, and I want to show you a case study of Airbus, which will kind of get home the point exactly what I'm trying to say. So let's go through this case study, and then probably I'll get back. And this is a comment from the person at Airbus. He's talking of the design engineer being a design jockey, no longer a design engineer, which means that he has to handle and he has to have the capabilities of judging which is the best design to pick, because his intelligence now has to move to pick the right design and not design the right design, right? So let's see this.
We are committed to reduce
Volume.
greenhouse gas emissions by 50% until 2050. This requires from us to develop new technologies which make airplanes much lighter. A lot of innovations happen behind the curtain. We have a dedicated lifecycle approach, a very holistic view, not only the product itself, but also the operations and how we manufacture the product. This enables us today to go a new way in airplane design, to use biological algorithms to go into a different kind of direction, how we design and manufacture components in the future.
To come up with new design principles, to find out what makes sense in the future. We call it bionic. This is what the nature has done for millions of years. That we are able to copy the nature, I didn't expect that, to be honest.
Certainly the bionic partition, as we call it, is also one product which has its roots in the biomimicry area. We have selected one of the most difficult structural components inside the A320 cabin. We can achieve this today is simply because we combine generative design, 3D printing, and additive manufacturing. You just say what you want and you will get it from the software.
If you think about the future and our task for the future, the biggest thing means we have to reduce weight. With bionic structures, we have a weight reduction potential of 50%. We have up to 95% raw material use, and we have the chance to reduce the production steps by 50%. This is really a very big step for an aircraft builder.
And this is just possible with generative design, using Autodesk software.
If this works, it works everywhere else. Now, step by step, we start to look for more cabin parts and see where we can implement bionic design.
I see here the biggest change I've ever seen. We have very long life products, you know. Each kilogram which we doesn't design in today doesn't cost fuel burn the next 25 years. It helps our customers, the airlines, and it helps the environment.
So just so that, I don't know how many of you caught those metrics, these were the achievements of just creating a partition through generative design. You can see for yourself, and those of you, I mean, most of you are in manufacturing, this is like music to your ears, or I'd say music to your eyes. So this is the kind of savings Airbus achieved by just adopting generative design and redesigning that partition panel which is there in every airplane, right? And all of us know these are the metrics which for the airplane industry matter a lot, whether it's CO2 emissions, fuel savings, and so on and so forth. What are the main benefits? Very obvious. You have multiple design options. You have virtual global teams operating because this is a cloud offering. And you have a great technology that is kind of fast evolving and unconventional design. So you would have heard this word constantly in that video called bionic. So the beauty about generative design is it does not think straight line. It does not think the way humans think. It thinks the way nature thinks. And hence those structures that get created are inspired by nature. They are bionic in nature. So they might not be the most pretty to look at, but they must be exactly what you wanted it to be with respect to weight, size, pressure handling, material handling, machinability, whatsoever you may want, right? Coming back to what are the main challenges, and that's what I'll cover now, okay? But before that, I thought,
What
let
if
me
you could come up
reinforce
with
the
thousands
generative
of
design
options for a
concept.
single design without drawing, all of which meet specific goals set by the designer? And from those options, pick the one design that delivers on the most important criteria, the design you couldn't possibly have imagined. This is generative design, a technology that harnesses massive computing power, creating forms with precise amounts of material only where needed, achieving maximum performance while wasting nothing. But generative design can be about much more than simply turning out alternatives. Prototypes can be scanned and equipped with sensors that provide real-time performance data that can be looped back into the design process, so the object, in effect, co-designs itself. And depending on the material and method of manufacture chosen, the software can optimize the design for those choices. In its search for the optimal design, generative design creates complex forms that would otherwise be impossible to make using traditional manufacturing methods. Now, with advancements in material science and the ability of 3D printers to print metal, companies like Airbus can create forms like this airplane partition panel that's half as light and just as strong. The result? Significant reduction in fuel costs and CO2 emissions. The things that have limited us in the past, software, materials, manufacturing, no longer do so. With generative design, the world can look and perform any way we want it to. This is the next stage in the evolution of design, and it's happening now.
The beauty about generative design being that so a typical 3D printing driven by an AI robot would print in parts, and then you would either join those parts through various forms. In generative design, depending on the machinability capabilities, you're creating a single structure, which I'm sure all of you would agree is a much stronger structure without any joints or anything, right? So basically, what are the challenges, right? So it's at the end of the day, it's we who are to use generative design. We as people need to use generative design. And basically, the typical thought that comes in a designer's mind is this technology going to replace me, right? So let me also show you one more case study before I conclude my presentation. This is a very interesting case study of a seat bracket, the seat belt bracket that we use every day. And you should see what General Motors has done with generative design on that.
There's many different ways to design for additive manufacturing, or maybe more commonly known as 3D printing. One of those ways is generative design. It really takes inputs of design constraints, load requirements, keep out zones where material can't be, and it generates thousands of different design solutions working with the software that maybe a single designer engineer couldn't come up with on their own. It's an expansion of our current capabilities, really focused on how are we going into the future with lightweighting, with new manufacturing process, thinking about designing and making our vehicles in a different way. Autodesk is one of our valued partners that we see as we go forward in the additive manufacturing space, really helping us from a thinking differently, the innovation culture that they can bring to us, as well as some of the tools that they have for design for additive manufacturing. One of the first parts we worked on in collaboration with Autodesk was a common rear seat bracket. This bracket consists of 8 pieces, welded together, bolted together. We worked very hard to consolidate that part into one piece, something that can only be produced using additive manufacturing. We ended up saving 40% mass, and again, got that part consolidation from 8 parts down to 1.
The benefit is really to be able to explore the design space in a much more efficient way than you can using a traditional approach.
We get multiple designs within a short amount of time, which is a feasible solution to our problem, which could probably take a normal engineer weeks to figure that out.
GM has traditionally always been a leading innovator in the industry, and it's great to see them adopting these new technologies and seeing how it applies to their business and to their customers.
We feel that there's huge benefits today, but then those benefits can really ramp up as we move into the future. Really, the opportunities for GM around additive manufacturing are endless.
I could have gone on and on with case studies. I have from Black & Decker. I have a case study from, I'm missing this company's name. So there are about 3-4 more companies where we have created these lovely case studies which kind of really get home the point that this is a technology that needs to be adopted. And by whom? Believe me, it pretty much is in all the sectors. So manufacturing is core to most of the businesses outside of services. So it impacts almost every sector because as I mentioned to you, every manufacturing starts with a design which is in your mind and then you take it forward, right? So I was mentioning about what are the challenges. The challenges continues to be, it's the mindset. It is the designers feeling threatened. Is my job at risk? Whereas that's not the case. On the contrary, you have to up your game. You have to up your game of assessing which are the parameters which are the most important, which is the second most important, which is the third most important. Get all the stakeholders to sign off on that because the rest the tool will do. Once you've defined your priority, that stress handling is my #1 priority, you will only see those designs which have high stress handling capabilities, and then you need to pick one from that, right? So apart from changing mindsets of our employees, our people, we have to change mindsets of customers because even customers think straight line, right? Customers have yet not started thinking in different manner. But if you give customers this awareness and give them this option, maybe they will challenging you to kind of come up with better designs. Obviously, you get plethora of design, so that could get overwhelming, and that is where the designers need to start building their skills of seeing how they can probably pick and choose. So the beauty is that in real time, you can actually select the parameters and it will keep changing the design for you. So depending on machinability or any of the other parameters, it really throws up the design based on what you have picked. With that, I pretty much come to the end of my presentation, which talked about future of making, which is where everything is heading towards in not a linear phase, but in a closed loop manner. Products are becoming more like a service with a lifetime value rather than a finite value. And of course, technologies like generative design are only going to make these digital enterprises work in truly the manner that they are envisaged to work. With that, thank you very much, and thanks a lot.
Thank you very much. So, Pankaj promised us something at the start of his presentation. He promised us that we will sit up and notice. Did he live up to the promise? Yes, okay, give him a huge round of applause. Ladies and gentlemen, thank you very much, Mr. Gauba. May I request Mr. Vijay Deshmukh to please step up on stage. Mr. Deshmukh is the CEO, Tagma Center of Excellence and Training, and we would request Mr. Deshmukh to hand over a memento to Mr. Pankaj Gauba, Head, Digital Manufacturing Group, India and Middle East, Autodesk India Private Limited. Please get your hands together, ladies and gentlemen, for Mr. Pankaj Gauba.